Just a quick note before we start section 4.3, day 2. I've been telling you guys for a while that the unit circle is a work in progress, that you will learn more and more. At the end of pre-calc 20, you only knew maybe 5-10% max about the unit circle. But with the last few days of information, you've actually kind of exploded in your knowledge up to 60-70% of everything you need. Once you learn what radians are and then the reciprocal ratios, you've actually gained quite a bit of knowledge. Now, at the end of the next couple of days, you'd probably be up way into the 80s, maybe even close to 90% of everything you need to know about the unit circle, again, which is a very, very powerful tool that is used all over the place in calculus. Today, what we are going to do is start with something that should look again familiar from your previous course, even if you forgot a lot of pre-calc 20. So here's where we are so far. We have done things like what is the exact value, so no calculators, no decimals, use the unit circle. What is the exact value of the sine of 60? Well, if we were doing the sine of 60, we would do the old y over r, and now we know again quite a bit more information with radians and reciprocals. Here's where the change comes in, and this again should look very familiar. Instead of saying here is the angle, now what is the exact value, we're going to be given the exact value, and we have to find, well, what angle or angles will work. So it's still the unit circle. The title, the unit circle backwards, is my code. It's not formal language. It's just to try to give you guys a way to remember it. Again, what we're saying is, here's the answer. Now, what was the angle or angles that would make it work? And there can be more than one. And when you learned this the first time, we kind of left this red little clarification in limbo until we were done, and then we tried to explain what it was. We might as well just say it right now. There could be more than one angle that actually gives this value. If we don't have this clarification that the angle, theta, must be between 0 and 360 degrees, there could easily be infinitely many answers. So this narrows it down. So then how would we do the solution for our very first problem? Well, it still is critical that you know that sine is y over r is always 1. So this is what it essentially narrows down to. We are trying to say what y value on the unit circle gives a positive root 3 over 2. That will be where we can find our answers. That would solve this problem. It actually is solving a trigonometric equation. So when we look at the unit circle, what I do is I just start on the positive x-axis and I start to lap around looking at the y values the second term. And I get to my first one. It is the 60. Sorry about using that as part of the example. So it's 60 degrees for the first time. We see that you would get sine being root 3 over 2. But then unlike before where we were a little bit in the dark, now we know more. If I keep lapping around, I immediately have another one. At 120 degrees, the y value is also root 3 over 2. Now, unlike again in our previous course, we know exactly where this is going. If I keep going all the way to 240 degrees or to 300 degrees, yes, they are root 3 over 2, but we rule those out because they have negative values. So there would be two angles where when we do the sine of them, we would get a root 3 over 2. It's 60 degrees and 120. And we have just solved the trigonometric equation. That is what this is essentially asking. Now, here is where, if you have a great memory, this might ring a bell from in pre-calc 20. I had a nickname for this, and I only said it once, so you're forgiven if you forgot it. I called this your happy place. When you are here, and if you understand the unit circle, it really isn't too hard of a problem to solve. But many, many times, you're going to have to get to your happy place. This is where we start to take it to the next level. Again, when I say you only knew 10% of the unit circle a course ago, then you start to realize it. Sometimes what you need to be able to do before you can begin is arrange it. You have to get to your happy place. You have to get to where it says sine of an angle or cosine or tan equals some value. So this one's fairly straightforward. What we would do in this is we would isolate the sine theta. We would start by taking 1 over, and then I'm going to do it at the same time. You guys are ready. Once you take the 1 over, let's divide the 2 off. So take it away. And we have sine theta equals negative 1/2. Now you're at your happy place. Now you can be going, sine is y over r is always 1. It essentially boils down to where would, and sorry if this makes a mess, where would the y value be negative a half because r is always 1. It doesn't play a factor. We go immediately to our unit circle. We are looking at y values, and I'm going to lap around very quickly because they're all positive up in quadrants 1 and 2, and I get my first one. At 210 degrees, I have a y value of negative a half, and also at 330 degrees. So we have two solutions to this equation. They will both work, and they both fall into the category that they are between 0 and 360, or else again we would have infinitely many answers. Now example C and I guess D and E start to show where there's a little bit more knowledge for us to gain, and then we will be able to say that we are 90% there, learning everything there is to know about the unit circle. For our next example, we have tangent. So tangent squared theta minus 1 equals 0, and don't get scared. I know this looks nothing like what you did in pre-calculus 20, but it's not going to be a bad solution, and then some fun things actually come up in the end, especially if you're a math teacher, you think these are fun. Here's how you'd begin. We need to get to our happy place, and how we're going to get to our happy place is we're going to start by bringing the 1 over. This means squared. Now this is a little bit of a new thing, so I'm going to write it down off to the side. Maybe I'll go to red over here. Because in every major math textbook in the world, they write a scenario like this in a compact form. If you had tangent of an angle and then imagine in a bracket squared, this is how it's written. You might think, well, that's a waste of time. That's just going to mess me up. A, get used to it because that's the way it is presented. But B, eventually you'll realize it's quite a nice form. It's going to save you time. It's going to be a lot sharper. So just know that that means the same thing. So then the question is, we have to get to our happy place. We have to get rid of the square. How are we going to do that? Well, let's square root both sides. So if I square root this side, well, square rooting will get rid of a square. If I square root this side, very nice, it is 1. And now we're at a pivotal moment. I've said that to you guys before. Anytime you're in this situation, when you square root, it becomes plus or minus. Now this is going to actually add a lot of answers. The very first time you're doing one like this, if you're like me, as soon as I see ones or even zeros, but we'll say 1 right now, my eyes start to go to what are called the quadrantals. So 0, 90, 180. It's not going to do it. And you've already seen the answers on the PDF notes. It actually is 45. If tangent is y over x, and now go immediately to 45 degrees. The y value is root 2 over 2. The x value is root 2 over 2. Dividing y by x, anything by itself, is a 1. You might not have seen that immediately, but rarely do you ever miss it again. So 45 is one of our answers. Now here is where there's actually more than just 2 answers, and this probably is the first time you've ever seen this. If we go to 225, it works out perfect as well. The y value and the x value are the exact same, and a negative divided by a negative is a positive, so 225 is also an answer. But now, because of our plus or minus, 135 and 315 will also work. Anything divided by itself is still 1. A positive divided by a negative is a negative, but we were allowed to have negatives. So there's actually 4 solutions to this trigonometric equation. All 4 of these angles will work. And maybe just a note, what do I mean by they will work? What would happen is if you typed into your calculator tangent of 45 or tangent of 135, 225, 315, you will get either positive or negative 1 when you hit enter in your calculator. That's what the solution actually is giving you. Once we move to letter D, well, then there's going to be no surprises. In letter D, we have 4 sine squared theta minus 3 is equal to 0. My apologies if I have to erase and continue the solution above. So first of all, you have to get to your happy place. You have to solve. When we solve this, the start will be to bring the 3 over. This looks nothing like what we need. Second step, maybe I'll write it down in full this time, will be to divide both sides by 4. Now you still might not be that happy. You see 3 over 4 if you glance quickly at your unit circle. That does not look very nice, but with one more swoop. If I square root this side, don't forget what that means. If we have, I'll write it up high here in the same spot. If you have sine squared of any angle, whether it's theta or x, doesn't matter. This really means sine x squared. And if I want to get rid of the square, I will square root both sides. I'll continue it right here. So if I square root, well, then the square goes away. Don't panic. Square root of 3, and don't touch a calculator. It's root 3. Square root of 4 is perfect. Now it's starting to look comfortable. We did a square root. We have to remember plus or minus. Now we're actually in our happy place. And I think I can squeeze the answers in down here. So if sine is y over r, and r is always 1. Sorry, that's a little messy. We're essentially into that same spot where we're just trying to say, where is the y value? Root 3 over 2. So it can be positive at 60, at 120, but now it can also be negative. 240 and 300 can also be included. So what we have is, yet again, 4 solutions. All 4 of these angles solve the trigonometric equation. And the unit circle, again, starts to show its power. It's a very, very powerful tool to be able to make these calculations at a higher level. Now, our final example in this set brings in a reciprocal. And it can cause people to panic a little bit. They wonder, well, how am I going to deal with this? How am I going to deal with something like secant of theta is equal to 2? It looks very strange. It's nowhere near your happy place. You might be very unhappy right now. Here's what I would recommend. I don't think well in secant or any of the reciprocals, but I do feel quite comfortable with the original sine, cosine, and tangent. So why don't we do the reciprocals? You have to remember that the reciprocal to secant is cosine. So we have cosine of theta. That would be the reciprocal. Now, wait a minute. You have to do the reciprocal on the other side, then we haven't done anything wrong. We're just going to flip both sides. Now I feel good. All I did was just rework the question. I didn't change anything. I'm not changing the values that we're looking for. I just said the reciprocal on this side, the reciprocal on this side. What you do to one side, do to the other. The math police cannot come and arrest us. Now I'm feeling good. Cosine is x over r is always 1, and then you find your unit circle. Where is the x value? A positive a half. It is at 60 degrees and at 300 degrees. Now moving on to number 2 in the examples, this is where, again, the unit circle shows its power again. It makes it sound like I'm too excited about it, but it really is a marvelous invention. I'd like to buy a birthday gift for whoever came up with this unit circle. In number 2, it again says solve the equation, but here's the change. This time for the kind of clarification, the bounds, the domain, if you will, it writes this down. Then you're thinking, uh-oh, what is going to happen now? Well, here is the only change. Instead of solving it over 0 to 360, it just says find the angles from 0 to 2 pi. It is saying find your angles in radians. And so really nothing changes. If you look at the first and only example that I put down, and sorry I put 2a, we don't need an a, we have 2 sine x is equal to 1. So you're not in your happy place, but very quickly you will be. We will divide the 2 over. Hey, now we're good to go. So sine is y over r. Now here's what's going to happen. What we really need to do is we need to look at, okay, so where is the y value a half? Well, that is at 30 degrees and it is at 150. But I'm not going to write down 30 and 150 because really what it asks for is the radian version. Well, I just said I wouldn't write it down and here I went and did it. So 30 and 150, great, those are right. But it wants us just to do the radian version. Well, that's right on the unit circle. 30 degrees in radians is pi over 6. 150 degrees in radians is 5 pi over 6. That is how we answer it. We can think this. Heck, we can even write it down. You don't even have to cross it out. But that is how easy it is to use the unit circle. What a marvelous tool. Now, our last example changes the bounds. The textbook gets a little crazy sometimes, but bless their heart, they're trying to prepare you guys for what's coming later. What they do in number 3 is they say solve the equation again, and they're going to change the bounds in a way that we haven't actually done yet. And there's been a number of you who have been emailing me questions about how do you do negatives, how do you go beyond certain bounds. This might clear a few things up too. So now what we're going to say is the angle, whatever angles we find, they're not going to be from 0 to 2 pi. We're going to be able to go backwards to negative pi and forwards to positive pi. So I'm going to draw a quick little graph and then we'll finish with this example. So here's how this guy unfolds. So right here is pi. What we're saying is starting right here, we can have answers anywhere up to pi, but not beyond. That's 180. So we can't go beyond into things like 210 or 225 or even into the 300s, 315s. We got to stop right here. But where the difference comes in is we can go backwards. We can do things like negative 30, negative 45, negative 60. Right here would be negative 90. Negative 120 would be about here. Negative 135. We can go and pick angles in here up to negative pi. That's what negative pi would be, and it ends at the same spot. So then how would you even begin this? Well, what we would do is we would start this way. We would start by just solving again, get to your happy place. And I think my example in the notes, which I'll finish, is a little poorly chosen. And then I'll just highlight it a bit more. So for this guy, what you would do is you'd still solve it, sine is y over r. Where is the y value going to be a half? Well, that's at 30 degrees and 150. And we can't go beyond. Now, I'm just going to add this in as an extra that's not in your notes. What if in the question we were allowed to be plus or minus? What it would mean is then we could get into the third and fourth quadrant. Now, here's what you would not do in this question. Where would the half be? That is a negative. Well, it's right here at 210 and right here at 330. However, we cannot be bigger than 180 pi. That's what this is saying. But we can go backwards. If this was actually the question, we could go backwards and we could end ourselves right here. That would work. And we could end ourselves right here as well. That would work. Now, how do you say this angle? Yes, I know in the unit circle right here it says 330, but this would be negative 30 degrees if you were working backwards, not forward. What would this be right here? That would be negative 150 degrees. So those would be two more answers if this was actually the way the question went, and we are still in the bounds. We're still less than 180. We're still greater than positive 180. Now, for a finish to today's notes, you might be like, uh-oh, I see a problem. He's answering in degrees. You have to answer in radians. Well, there's where the beauty of the unit circle comes down. 30 is simply pi over 6. 150 is 5 pi over 6. And then negative pi over 6 and negative 5 pi over 6. So when you do the assignment today, what you will see in the PDF notes is I wrote 4 questions up on the board to solve. It says assignment, and then there's a set of questions out of the textbook.